I'm gonna ask Beau to just briefly at the beginning of his presentation to just kind of give a brief background on what Alabama Cooperative Extension Service is. It's just a really great organization that's been around for a very long time, that does a great job of public outreach and education to the communities as well as individual homeowners. We have an office at the Birmingham Botanical Gardens where the Master Gardener program is run out of, but also you can just call them up if you have a spot on a leaf and you want to know what it is. You can take plant materials and bugs into their lab and they'll tell you what they are. And there's just a ton of resources right here locally on, your own garden. Beau is actually the community forestry and arboriculture extension specialist based at the Gulf Shores office now, I think, Beau. You can correct me if I'm wrong. Okay. But his remit is the whole state of Alabama. So he covers a lot of ground and has a lot of years, nearly 2 decades under his belt in urban forestry and forestry at large. So he is also an affiliate faculty member at Auburn University in the School of Forestry and Wildlife Sciences, has a PhD in forestry. He's certified by the International Society of Arboriculture as a certified arborist. And I think I mentioned he has a PhD in forestry. And oh gosh, what else? He sits on the board of trustees for the Tree Fund, and I'll let Beau explain what the Tree Fund is. Gosh, I think that covers his credentials. I first met Beau, I guess like 2015 or 2016 when the Nature Conservancy here in Birmingham led by, there was a project led by Francesca Gross at the time, doing a tree inventory in Birmingham in one of the parks. And I attended to, there was a training session. You could learn how to do tree inventories. So I attended that. I was really interested in bringing that to Homewood. I was on the Homewood Environmental Commission at the time. And we ended up bringing a tree inventory project to Homewood. Beau came and presented to the council on what tree inventories were, the different types of inventories you could do, what the benefits are. And we decided to do a sample-based inventory for the whole of Homewood covering 200 sites. And we almost got finished before the winter of 2019 hit and then had to wait. And then so spring of 2020, we couldn't finish because of COVID. So I've come up with a way that we can finish it now. So we'll get started doing that again this spring and summer. But Beau came and trained all of the volunteers that were going to go out and do the tree inventory in Homewood. So hopefully we can have him back when we finish our tree inventory and present the results. And I know he's going to help me do the analysis on that. Right, Beau? So that's all very exciting. So I've had the pleasure of working with Beau on and off now for a few years, primarily on the tree inventory stuff. So, and actually the topic for tonight was one of the topics covered by some webinars that Beau has been running for ACEs. I think they're called Raising Tree webinars, and it's all these different topics, like every Thursday almost, on trees. And the topic tonight was one of those. And so I thought that it would be great for him to present that to Homewood, because we're currently reviewing and drafting. Well, I think the drafting stage is over, but we're currently reviewing a new tree and landscape revisions to the zoning book. This has been on the table for years, but we're finally at the end of that now, and council and planning commission are making any final minor changes to that. But protecting trees during construction is new to those regulations. It's a big part of it. So this ought to be timely, relevant, and interesting. So let Beau take it away.
Thanks, Amy. And yeah, you brought up raising trees, and Michelle, I just sent you a link to our blog page, and maybe you can resend that out to the group. So
okay, I'll do that.
Let me share my screen real quick.
Okay.
So thank you, Amy, and appreciate being on here this evening, presenting on tree preservation during construction. As Amy said, I work for Auburn University Extension. A little bit about Extension. all of our land grant universities, of which in Alabama, Auburn is our primary land grant institution. And our land grant systems have 3 arms, and those are education, research, and extension. And so in extension, our responsibility is outreach. So we serve as conduit between practitioners and the research at the university. And so in my position as extension specialist and affiliate faculty in the School of Forestry is I do predominantly research. I mean, I do predominantly outreach, but a little bit of research as well in the fields of urban forestry and arboriculture. And so the topic I have for you today, oh, and she mentioned, I was going to say something about Tree Fund. For a few years now, I've been serving on the board of trustees for Tree Fund, and it's a fantastic organization. You can, if you just Google Tree Fund, you'll find them. They're an philanthropic organization that raises funds to support research in the fields of arboriculture and urban forestry. So a lot of the applied research that's emerging in a lot of fields is being funded by the Tree Fund. As we have increasingly less and less applied research support from different organizations, and Tree Fund has really stepped up. And so I've been helping Tree Fund for the last few years, serving on their board of trustees. But with that, we'll talk about tree preservation. This is a great topic, especially for a lot of our communities in Alabama. We have a number of challenges across the state. There was a report published, some research from 2018 that suggested that in Alabama, we were ranking pretty low as far as canopy loss. We were losing about 2% of our canopy a year. And and one of the big issues is development and construction. Depending where you are in the state, I know the Birmingham metro area has a lot of population growth. I'm down here on the Gulf Coast in Baldwin County, one of the fastest growing counties in the state, and actually probably one of the fastest growing in the country. And what we see is a lot of obviously new development. So whether it's forest land, farmland being developed, but we also see a lot of infill development. And so you see, and I imagine you probably see some of that in Homewood, where you have kind of older homes being replaced by newer homes. Oftentimes the newer homes are much larger, and you end up with less space for trees. And so it's a big challenge to try to understand, how do we preserve trees during the construction process? And this is really not a very difficult process, but it's very poorly understood. And I've been back and forth with builders and architects, and my wife's an architect. And it's funny, I've had builders tell me they've never killed a tree, and what I've come to understand that means is they've never killed one within their 1-year warranty. Because I'm usually the guy that gets called out 2 to 3 years later to look at projects, because we have to understand that trees are long-lived organisms. So they're fine. They'll have energy reserves in many cases for a year, 2, 3 years. But as the damage accumulates, you end up having these issues show up, 5, 6 years after construction, depending on the species of tree, its health, maturity, and various other factors. So in this presentation, I have 3 goals. One is to give you a basic understanding of tree function and structure. And then the second part of the presentation is going to talk about the impacts of construction on trees. So basically how we kill trees during the construction process. And then I'll conclude the presentation with tree preservation strategies. So as I've mentioned, trees and, people and trees, we often collide. We end up with diseased trees. This was a picture of a project a homeowner had called me. This was just down the road from me here in Fairhope. Beautiful new townhomes were built, and had a southern red oak in the front yard. And about 5 years after construction, they noted that the whole top of the tree was dying out, and wanted to know, what on earth this pest was that was killing this tree. And a colleague and I, we coined a term, and we call it the people weevil. And so we are sometimes our own worst enemies. And it was the construction process that really caused the issue with these trees. But in a lot of other cases, it can lead to dead trees when the construction process is egregious enough and we've caused enough damage to those trees. This is a tree down the road here as well at the Grand Hotel, at Marriott's Grand Hotel. I'm not sure if you visited. They did a bunch of renovations a number of years ago, and they're known for their live oaks, but they lost a few, not understanding how to preserve trees during construction. And of course, when we damage the trees enough, when we cause enough root damage, it is possible for those trees to fail and cause property damage. This is a picture I took after Hurricane Ivan, and we just had Hurricane Sally blow through this area and Zeta blow through it a little bit later. And so, especially if you're in areas like we are down here on the Gulf Coast, when we cause root damage, we not only have to worry about losing the trees and having them die slowly, but you can have catastrophic failures as well. And of course, when you have catastrophic failures, you can have a threat to public safety. When trees come down, they can cause a lot of damage and they can fall on people. Statistically, it's not many people are killed and hurt by trees on an annual basis, but it only takes a few for it to show up in the news. So I like to point out that a significant contributing factor is the urban environment in which we are, and how we manage trees in the urban environment. And we do a few things like tree placement and design. Quite often we put the wrong trees in the wrong place. We don't think about the system we're designing in the long term. We also tend to have in a lot of our municipalities limited urban tree management and maintenance. It takes a lot of money to maintain trees. And a lot of times in many communities, we still struggle getting municipalities to understand that trees are an important part of the community. We have a growing body of research that's showing a lot of the economic and ecological values that trees can provide a community. And to be able to ensure that you have those trees in the long run and that they remain safe, you have to have the budgets to be able to maintain those trees. And of course, part of that is damage from construction and development. And I was sitting in this week with a committee with some council members with the city of Mobile who are redoing their tree ordinances, and they're actually updating the ordinances to include some tree preservation standards that are in line with the best management practices that we have today, as opposed to something that is kind of a very minimalistic, just barely get by. They were trying to expand the tree ordinances to have tree protection zones that were actually big enough to actually have some type of success. So one of the issues a lot of times we have is when you talk to people about trees and tree preservation, quite often there's a lack of understanding of how this process works, how trees grow, and how we get ourselves in trouble. And I like to point out that we have to remember where trees come from in their biological needs. And so trees come from these communities of trees we call forests, and very often we have a lot of complex interactions that are going on in these forests. We have unrestricted rooting space. We have natural soils. I mean, just look at that picture in the background. We have, leaves and branches, and we have this composting process that occurs with plenty of organic matter. We have natural drainage. We understand the sylvics of trees. Certain species like to grow in certain areas because they have certain moisture requirements. But in the construction process, we can take a tree that's been in a certain place for 30, 40, 50 years and adapt it to that environment and very quickly change the drainage. It can suddenly now have wet feet all the time because now it's the lowest point on the project, or possibly the opposite. Now it's going to be a lot drier than it was in the past. Also, when we look at the natural forest systems, trees have shelter and shade from surrounding trees. And this becomes real important, especially when we look at storms and wind. The ability for these trees to be able to work together as a system with the buffering of winds and those storms. And it works a lot better than these individual specimens that we kind of sprinkle around our yards. And probably one of the biggest issues that we have in the urban forest that we have in the natural forest that we don't have in the urban forest is a slowly evolving ecosystem. So when we look at our forest system, things don't happen very quickly. I mean, yes, we can have, wildfire and some things like that. But in the urban forest, in a matter of just a few months, the tree can lose a substantial portion of its root system and have a lot of challenges that the tree has to adapt to very, very quickly. And so I like to point out that, in nature, trees can take care of themselves. This was a pecan tree that got blown down in a hurricane, several decades ago and just left to their own devices. A lot of times trees can adapt to a lot of situations. But when we look at the built environment and construction, trees really need our help, in the urban setting. This was a picture I took a number of years ago where a homeowner had called me and wanted to know why all the oaks in their yard were dying. And it was a brand new neighborhood, and all I had to do was ask them to walk down the street with me, and I could kind of walk them through the construction process and what happened to their trees and why it is now that 2 years after construction, their trees are starting to fade out. So instead of a forest, a lot of times in the urban forest, we have plugged trees into a much harsher environment. We've pulled these willow oaks, out of the, floodplains they like to grow, and then we plop them, in these spots right between a street and a sidewalk with perfectly manicured grass. I'm sure there is not a herbicide in sight that's used on those trees to maintain them that way. And then we expect these trees to thrive in these environments. And if you deal, and I think I have a picture of this, and you deal with sometimes the street departments and the engineers who love perfectly straight lines, and my brother's an engineer. And when trees buckle sidewalks, they love to come in and, grind off the roots. And we end up with these environments that are just changing, almost continuously. And the trees are subjected to all these change. And it's no wonder we have a lot of the issues we have in the urban environment. And so I like to point out that most mortality in our urban trees begin with abiotic factors, non-living factors. And so when we stop and think about it, it's going to be things like root removals, soil compaction. We're going to bury root systems when we have grade changes. We have changes in drainage. We have changes in soil chemistry. All of these things happen. And I'll talk a little bit about each one of these. And so there was a model that was proposed, back in I think it was like early 1990s, called the Mannion decline spiral, proposed by Dr. Mannion, that basically kind of shows us how it is trees die in a lot of cases in the urban environment. And so if you look at this, and let's see if I can get this to work. We start up here with, these predisposing factors. And so when we look at our predisposing factors, this is kind of what causes trees to go, as we look over here on the left, from healthy down to stress. And, on the top of that list is the urban environment. We also might have the genetic potential for the tree. Of course, in urban environments, a lot of times we're going to suffer for things like poor soil compaction, poor fertility. If you've ever seen the construction process, especially for some of our larger subdevelopments, the earth moving machines a lot of times remove the O horizon or organic layers. A lot of times we lose some of our A horizon, and there's good engineering reasons for that. We're trying to make sure we have good foundations that don't have settling later. But what that results is a very poor median for growing trees. And so it pushes trees from this healthy area down towards stress. And then we get these inciting factors. And a lot of these are quite often very natural. They might be defoliating insects. Maybe we get red-headed pine sawfly. We get, some type of minor leaf fungus, whatever it might be, things that for a normal, healthy tree is no big deal. And I tell people, most foliar issues with trees, it's no big deal. You really don't have to worry about it. It's aesthetic. However, when you combine it with a lot of these other factors that might be going on, and you start adding regular defoliations, or maybe, as we had here a few years ago recently, drought. So now we have maybe a prolonged drought, maybe 1 or 2 years in a row, and now we start pushing trees further into stress and maybe even towards declining. And then, of course, we get these contributing factors. And in my experience, this is usually where lay people, really the bells start going off in their head that there's an issue. Because at this point now we start to see canker fungi, right? We start to see the fruiting bodies of mushrooms showing up at the base of the trees, on the tree trunk, because we've got some sort of internal decay. We might see wood-boring insects. We might see, Dendroctonus pine beetle, who are attracted to stressed trees. And so now all of a sudden these things are causing sawdust at the base of the tree. And that's usually the last straw that pushes trees from declining down to dead. But if you stop, and a lot of times you unwind this spiral, you'll see that progression of processes that happen. And a lot of those were just, urban environment followed by a lot of times some type of construction damage. And then some of those natural processes like insects that push those trees over the edge. And so many problems begin, with the roots, in my experience, is, where we get it wrong during the preservation process is below ground. And so, take, for instance, this, brand new, beautiful sidewalk with a gentleman that's quite proud of it, not realizing that we pretty much cut significant amounts of roots on both of these trees and probably made them quite dangerous for future windstorms. And so I love this quote by Dr. Alex Shigo. He was kind of the grandfather of modern arboriculture. And he said that if someday we are to know everything there is to know about the above ground portion of a tree, we will still only know half the story. And it's that half the story below and it's I hear people say all the time that roots only go as far as the drip line. It's as far as the root go. As long as you stay out of the drip line, you're fine. And I hear thoughts that, roots, the trees have tap roots, or trees have these deep roots. A lot of times there's this notion in people's mind that root systems are a mirror image of the above ground portion of the tree, these kind of deep roots that are tapping into some deep aquifer for moisture. But a lot of these ideals, while commonly accepted, are not based in any type of reality. So I like to pose this image. This was based on some research and some artwork done by a group at the Morton Arboretum up outside of Chicago. And this is a field-grown white oak, and they excavated the entire root system. And it gives you a much more accurate view of a root system. And you have to realize root systems are going to vary a little bit by species. They're going to vary by soil type. But this is going to be closer to what you could expect in many of our hardwood species. And what you'll note is that the root systems are widespread, a lot of times going 2 to 3 times the drip line. They're also shallow. 90 to 95% of the mass of a tree's root system is going to be located in the top 2 feet of the soil profile. And we have to remember that, the function of roots is to absorb moisture with dissolved minerals. That's how trees, in quotations, feed themselves. And we also have to remember that these roots provide structural support. So if you've ever watched one of these massive trees during a thunderstorm and wonder how on earth they're standing, it's really, complex physics. And actually, there's been a lot of research in the last 15 years looking at tree biomechanics. And so one of the areas that gets us in trouble from a safety perspective with trees is when we see damage to this area called the root plate. And so the root plate, it's an area of rapid root taper, and it's where you're also going to see your deepest roots. So these are your roots that really anchor the tree to the ground. And I like the analogy that Jim Urban, a well-known landscape architect, posed, where he said, if you take a wine glass and place it on top of a dinner plate. And in that analogy, the dinner plate is your extended root system, and the base of your wine glass is your structural root plate. And so when you cut part of your dinner plate away, you're affecting the biological capacity for that tree to absorb, moisture and minerals. And so you might see it eventually show in the top of the tree with kind of some dieback. However, when you start cutting into the root plate of that tree, you now not only affect the tree biologically, but you affect the tree structurally and run the risk of a tree that could potentially topple over time. And we'll talk a little bit more about that in a second. So let's spend a few minutes talking about how we get ourselves in trouble during the construction process. Probably one of the most common is, a physical injury. The guy with the skid steer not paying attention dings the side of the tree. And I don't care how careful people tell me they're going to be, I almost always see this on a construction site. And the problem with this is we have to remember that the bark allows the tree to keep the moisture within the tree, keeps a lot of the fungi and pathogens out of the tree. We look at the wood within trees, it's a bunch of complex sugars. And so as soon as you remove and open the interior of that tree, you now are going to have the introduction of fungi, and you end up with this race between how quick the trees can seal that wound and how fast the fungi can begin to rot away at the inside of the tree. And so we have to remember that trees, they don't heal, they seal. And we have this process called compartmentalization. And it's a process whereby the tree forms different layers to try to keep decay at bay. And in the theory of compartmentalization, we call those walls. And so you have a wall that forms, if you can imagine a tree that goes up and down, you have a wall that forms above and below. And those are quite often where the trees plug up their conductive, basically it's like a bunch of straws within you, and they plug those up so that the decay fungi can't move up the tree and hollow it out. And they have chemical barriers that don't allow it to move further in towards the interior of the tree. And then of course it has, every year it puts on a ring of growth. And so when it's doing that, it's going to try to start sealing that wound. However, trees, it can take them years to seal that over. And so during that whole process, you have the tree kind of open to continuous attack by various decay pathogens. So it's something if you can avoid it, it should be avoided. And of course, depending on your species, some species are pretty adept at compartmentalizing decay. Live oak is fantastic at it. But other species like water oak or laurel oak, this is a water oak in this picture, are terrible at compartmentalizing decay. This is the previous city forester in Mobile, a picture I took years ago after Hurricane Katrina, I think. And of course, you can see a tree here that, we have what looks like damage down at this base of the tree, and you can see where the path of decay probably worked its way into the base of the tree and hollowed the tree out over a number of years. Now, the other big issue we run into during the construction process is root removal. And when you start cutting away the roots of the trees, once you get past 40% of the root system damage within a tree, survival really becomes questionable for that tree. Now, if trenching happens, like you see in this picture here, this was a tree in the city of Mobile where the streets department came in and put in a brand new sidewalk, beautiful straight sidewalk. But if you'll note, we got massive roots cut all along here. And so this is well within the tree's root plate. And so the city forester and I looked at this tree, it's been a couple of years ago, and he's really worried about the potential for this tree to fall. And it's a big enough tree that if it falls, it could fall, either on the house on the other side of the sidewalk or on the house on the other side of the street. And we have to remember that in those scenarios, that when you cut those roots, you not only lose the immediate strength, but you end up with these decay pathogens, and very often they'll kind of work their way up the trunk and into the base of the tree. And so you not only lose immediate strength, but you have the potential that decay pathogens can further weaken that tree over the years. And when it gets bad enough, they do fall, and particularly in windstorms. Down here we had Hurricane Sally, and a lot of the trees that went, or not all of them, but a lot of the ones we noted had some previous things like root damage that caused it. This is an article I found a few years ago from the city of Minneapolis, where the street department had come in and cut a bunch of roots for a new sidewalk, and some straight line winds had come through and knocked a series of trees down on top of cars within the city. So, cut roots is pretty obvious, but, you still see it quite often. One that's a little less obvious to a lot of folks is changes in grade. So burying the tree's root system. I love this image here from Dr. Gilman at the University of Florida. He did some research, gosh, it's probably been 15 years ago, where he purposefully planted a bunch of trees too deep. And what he found was, the root systems want to be near that soil surface. And so you'll note the tree will be growing right back up towards the soil surface. So that works for younger trees. If a tree is young, is vigorously growing, it's a species that adapt to this, they will grow their root systems back to the soil surface. The issue is when you have a grade change on a tree that is mature or over mature, very often those roots will decay and die over time. And so, you can see these types of situations where people have tried things like wells, and wells like this really don't work in most cases. All you're doing with this is keeping soil away from the base of the tree, which, is helpful to a point, but really the whole extended root system on these trees has also been buried. And over time they can rot. And when they rot, this is a tree that went down here after the hurricane, after Hurricane Sally last year. So the question always comes up, says, well, if I was going to change the grade, how much soil can I add over my root system and get away with it? And what you have to remember is that one of the problems you're having when you add soil to the top of a tree is that trees' roots to grow need moisture. That moisture is coming from rain. They also need oxygen. And so when we put soil on top of the root system, we're going to limit to some degree how long that takes for that moisture to get down there, but we're absolutely going to limit the oxygen that is getting down to that root system. So how much soil you can put on top of a tree's root system is dependent on what type of soil you have. If it's a pure clay, which has a very small soil particle and has very little void space for air, as little as 1 inch over the entire root system of the tree could cause issues. And we have to realize quite often when you're adding soil to a root system, you only might be doing it to a portion. And that's different, but we're talking here theoretically if you're changing the grade all around this tree. And of course, if you're dealing with a pure sand, you can get away with as much as 8 inches because there's so much pore space. There's going to be so much infiltration of moisture and air into that soil. And we know that, an ideal, and so one of the other, I thought I had another slide on that. One of the other challenges we have is soil compaction. And this is one that's really kind of, I like to call it the silent killer of trees because it's something that happens sometimes relatively slowly, can be over a period of time, and it kind of sneaks up because the symptoms show up much more slowly. And we know that an ideal soil, before I jump, is, theoretically it's, 50% minerals, 45% pore space, and 5% organic matter. And it's that pore space that's really important. We need those voids within the soil for air and water. That's why, when you buy a potting mix, at the Home Depot or something, those soils are so light and fluffy. They have a lot of void space in that soil for air and to hold moisture. And so, with soil compaction, when we have heavy equipment running across the root systems, we have to remember a lot of those feeder roots are going to be right up near the soil surface. And so when you have heavy equipment, immediately you can have some of those roots automatically crushed. But over time, the soil becomes compacted and you have less oxygen movement, and those roots that are down deep, begin to decay and die away. If the tree's young enough, it'll grow basically a whole new root system up towards the soil surface. But if it's old, over mature tree like this live oak where they paved around it, it's not getting water, it's not getting oxygen, and you can see the dieback. The trees tend to die from the outside back towards their center. And so when you see a tree you see a lot of dead limbs at the tips of the branches, warning bells should be going off in your head that you have issues. This tree is no longer there. It actually failed a number of years ago. Just some other images of ways we get ourselves in trouble with compaction, sometimes stockpiling material under the base of trees. Of course, the favorite place for any worker that's on your construction site to park is in the shade up under your trees. A few times is not a big deal, but over a 6-month construction process, it begins to add up. And of course, moving heavy equipment, so if you've got a tree at the front of your property, you're building towards the back, and you got the cement mixer and the truck that's dropping off all your supplies, you got this regular movement of traffic, you are compacting that soil. Kim Coder at Georgia, University of Georgia, did some research a few years ago, and he basically found that under the right soil conditions, and those right soil conditions generally mean wet soils and certain soils, so your clay soils are going to be much more compactable than your sandy soils. He found that you can compact a soil up to 95% with as few as 3 passes. I would argue that in most cases it's going to take more than 3 passes, but it can happen very quickly. And of course, what type of equipment matters? Even as people, we put some PSI on, weight on trees, but certainly as you have vehicles parking and as you get into heavier and heavier equipment, the compaction issues become more drastic. And so what happens to trees and roots under these compacted soil conditions? Well, one of the first things that happens is soils become anaerobic. So what happens is, as you have less air moving into the soil, you don't have oxygen moving into the soil. And so when the decomposition process, so we have microorganisms in the soil, and as those roots begin to die off, we have the decomp process occurring that releases CO2, and you end up with these pockets of CO2 kind of locked in the soil, and then that puts pressure on a lot of the microorganisms, and there's just millions of microorganisms in our soil, and most of these are beneficial for trees. A few of them, of course, are fungi that are damaging, but a lot of them, we need them to be there. And so as these begin to die off because of compaction, suddenly your root systems also die off, and you end up with very shallow rooted trees should they survive the process. And as you compact the soil, a study done, 20 plus years ago, found that when you compact a soil down to 12%, from that 50% pore space down to 12%, you reach a point where a root can physically no longer grow. It's basically the soil is now pretty much concrete. And so what we found is that, when you look at these compacted soils, because those soils it's difficult for those roots to punch through, the roots become kind of short and stubby. So you don't get a widespread root system. You get a much smaller root system. You also end up with very shallow rooted trees. And the problem with shallow rooted trees is you have less physical space for those roots. Trees already like to have their roots within 2 feet, but with a really compacted root system, you might have a lot of those roots now within the top 6 inches of the soil surface. And so when that happens and you have, hot periods or periods of drought, those top few inches of the soil dry out a lot faster. And then you have the trees that are much more susceptible to drought issues. Also, we see this a lot, and I think I got a picture. Yeah, when these roots are shallow, they're much more likely to damage infrastructure. Of course, they're also a lot less stable, and I can't remember if I added a picture. No, I didn't. They're also a lot less stable, but also one of the issues you run into is, I get a lot of calls from people that say, well, I'm seeing all these roots pop up in my yard. I had these trees, a few years, they're getting bigger, but now all these roots are popping up in my yard everywhere. And a lot of these sites, tend to be, big subdevelopments that were put in where they really compacted those soils. And all that's happening is those roots are shallow rooted. And, just like the tree puts on a ring of growth every year, so do those roots. And as they get bigger in diameter, suddenly they start to become noticeable and start popping up in people's yards. And now you have mower conflicts, which means you're starting to ding them with the mower, which introduces decay. And you can see that whole cycle kind of starting off there. And we did see a lot of this, these with shallow roots, you don't have those sinker roots going deep. And when you have, storm events, especially when you have lots of rain followed by wind, you see lots and lots of tree failures. Down here with Hurricane Sally, we had, 2 days of rain before we had 4 hours of 100+ mile-an-hour winds. And with that, a lot of the shallow rooted species completely went over, especially either not species necessarily, a lot of the shallow rooted trees that were in compacted sites. One of the other challenges we have is soil changes in soil chemistry. The big one I see is concrete washout. I've seen, you just look at this picture and we got, sand piled, and I've seen folks washing out the concrete truck or washing out. I was at a homeowner's house a couple, 2-3 years ago, and they were washing out. They were doing a small project in the house, and the guy was just washing out all the concrete up underneath the trees. And if you look at the pH of concrete, it's something like 12, and the ideal range for a tree is going to be 6.5 to 7. And so if you're doing enough of that, you can end up with some really funky pHs in your soils, which is going to affect your tree's ability to absorb minerals. And so that gets us through a lot of the challenges that we see, how we damage trees. Now, how do we get around it? And as I said before, this is really not a very complicated process, but I'll lay it out for y'all. So one of the first things I'll say is there's a planning sequence, and it begins with the planning phase, and we'll talk about each one of these individually. And first, you're going to determine the trees that are worthy of preservation. Just because it's there doesn't mean you should keep it. 2, we have a design phase, where you're reviewing your design in relation to the trees that you're hoping to preserve. Then we have a pre-construction phase, where we're reviewing the construction plans to develop a tree protection strategy. Then we have a construction phase, which is really site monitoring at that point, and then post-construction. And we'll talk a little bit about each one of these. I will note that good tree protection and design happens during site planning and prior to construction. I can't tell you how many times I've gotten calls from people when they are halfway through the construction process and they're starting to become worried because they're seeing chunks of roots laying around everywhere. And I have to tell you, you can't glue them back on. And so once those roots have been cut, you move into a mitigation place, and mitigation is far more expensive than preservation. And so good tree preservation happens, early in the project, and the more people that are going to be, whether we're talking about a several 100-acre development or the house you're building on your lot, you want to get everybody involved that's part of that construction team. If you have a planner on the project, if it's a big city project, you want the planner, you want the architect, the builder, the engineer, if you have to have one on the project. If there's going to be a landscape architect, the city manager, and the urban forester. If all of these people can sit down and get on the same page and look for solutions, you'll be successful. But if you only get half the team there together, it becomes increasingly more difficult. So the planning phase, this is the phase where you're going to inventory the trees that are out there. You're going to assess their condition, and you're going to determine which trees are worthy of preservation. The question you should be asking yourself is, what's the chance this tree is going to be around in 10 years? It's hard to go through the preservation strategies for some overmature tree that already is showing signs of decline, maybe already has some structural issues that's not going to make it the best tree to have near your house anyway. And so you want to have a professional come out and look at this. And this is a great time to hire a certified arborist, to have somebody evaluate your trees, let you know which ones are healthy, which ones maybe might have structural defects, that maybe it's a good time to have that tree removed anyway. And kind of look at the trees that are out there before you move into the preservation strategies. And so a few things to consider. Overmature trees are difficult to preserve. Just like us, the older we get, we don't react well to sudden changes or illnesses. And you have to remember, even the best of tree preservation around trees, they're going to lose some roots. There's going to be a little bit of compaction. There's always going to be a few things going on. And so if they're already in that overmature declining stage, they're going to be poor candidates. You also have to realize that some species are more sensitive to root damage than others. Down here on the Gulf Coast, live oak, Quercus virginiana, is a fantastic tree. They're very resilient to construction damage. So kind of on the other end of the spectrum is American beech. It's very, very sensitive to construction. And as a result, you kind of want to keep that in mind. Also, some species are more susceptible to decay and diseases. And so having an arborist that can kind of let you know which trees are going to be easier to preserve, which ones are going to be a little more difficult, is important. And also small and medium-sized trees are going to also be easier to preserve because they have smaller root systems. And we'll talk about this idea of a critical root system. And, you know, when you try to measure that and how much you have to keep, what the larger the tree gets, the bigger that critical root system gets. And you start to realize, depending on the size of your lot, how difficult that might be. And of course, you should always have the tree evaluated for risk, making sure you're not preserving a tree that's got massive defects that could cause the tree to be unsafe on your property anyway. So then we move into the design phase, and this is, you know, ideally it's happening, your architect, if you're hiring one, understands that, you know, tree preservation is important, and you can look at your tree and your design in relation to trees. And so here's a blueprint, and what's funny about this blueprint is that if you look, you know, we got the blueprint here, and if you look, you know, at these little blobs right here, you know, those are signifying trees, but it's amazing that that right there is signifying a 43.5 inch post oak. That is a big tree. And it's going to be a tree with a very large critical root zone, but I'm looking at it and it's very close to all these lines of disturbance. We've got, you know, grade changes occurring. We got underground utilities. We got a lot of stuff going on. And when you look at that, it's going to be impossible to realize, can I preserve this tree or not? You know, what do I have to change on my property? So really the first thing you have to do is develop your critical root zone for the tree. And so what the critical root zone is it's the root system that the tree has to retain if you would have any hope of that tree surviving the construction process. And you measure the critical root zone as you take your diameter at breast height. So that is measured 4.5 feet off the ground. And you take your diameter at breast height and then you multiply it against a multiplier. Now that multiplier is going to be anywhere from 0.5 to 1.5 feet. So you kind of multiply inches against feet. And so, you know, for example, so if you have a, you know, a 21 inch tree, and, you know, you're going to multiply it against a multiplier of 1 foot. So for every inch in tree, you need 1 foot of radius if you're going to expect that tree to survive. Now, the multiplier can vary a little bit. And this is why it's important sometimes to have an arborist on the project, because that multiplier will vary depending on the species. Remember, we said some tree species are more sensitive to damage than others. We also know that, you know, as trees become older, they're also more sensitive. And so that multiplier is going to change a little bit, but we have some tables out there. This is from the best management practices of the International Society of Arboriculture. And you see that, you know, over here we got species tolerance to construction, high, medium, low, and then the relative age of the tree, young, mature, and over mature. And then it kind of shows you that multiplier. So, you know, if you have a tree that's, you know, very high tolerance to construction damage, it's young, you know, we can basically say your multiplier is going to be, you know, 0.5 feet, 0.5. Now, we also know that if it's, you know, it's got a, you know, very high tolerance to construction, it's mature, it's going to be 0.75. And of course, you know, you can see where those go through there. In my opinion, you know, somewhere around 1 foot for each inch in diameter, at diameter of breast height is a pretty good multiplier. So if you know the tree is real young and vigorous, you could probably get away with 0.5 as that multiplier. And so you go back to your building, and then you know, as you look at your designs, you ought to be putting that critical root zone in the drawings. Because what this will show you is it'll show you how much of that critical root zone am I going to lose? Because you have to remember, this is not the tree's entire root system. This is the critical root system, meaning that if you start losing any of that critical root system, your chances for success on the project are going to drastically decline. And so, you know, look at these trees that are here. And this one, you know, we're looking at potentially losing, you know, almost a quarter of the tree's critical root zone. And in most cases, if you're going to be losing that, you know, it's going to be very questionable whether that tree is going to survive. And so based on that, you now have to decide, okay, can we move the building? What can we do to accommodate for these trees? And or looks like we're going to have to remove the trees if you can't redesign around it. And I can tell you it's a lot cheaper to remove the tree when you're clearing a lot than it is when you've got a massive tree overhanging a piece of property. If you've ever had trees removed, you know how expensive it can be. And so, you can go in, figure out where your property is and which trees have to go, which trees might be able to stay. Now, something else to keep in mind during the design stage is to plan travel corridors and material storage areas and workspaces. This is a picture I took up the road from here. If you leave it up to the construction crew, they will drive anywhere they want. They will park anywhere they want. They will store materials anywhere they want. And what they're doing is they're dinging those trees. They are compacting your soils. And you end up with very unhappy trees, 4 or 5 years after the project. And so instead, what you ought to be doing is planning your travel corridors. How are they going to get into the project? Where are they going to turn around? Where are they going to stockpile the materials? And you have this all planned out. And hopefully, you're doing this in conjunction with your builder, because unless you're a builder, you may not know exactly how much space they need, how much space they need to turn around, and so on and so forth. And of course, put fencing up, and I'll mention this again later, but it's not good enough just to plan it and stake it. Go ahead and put some fencing up, because you want to let people know where they can't and should go. Let's see here. And so then we moved into the construction phase. So these are developing tree preservation strategies. And so you have your CRZ, remember that's what we just measured. And then you have this idea of a TPZ. And so this is your tree protection zone. Remember, your critical root zone is the absolute minimum that tree really needs to survive. And you shouldn't ever work on minimums. And so when you're putting up your tree protection fencing, if you have more space to give that tree, give it an extra few feet. And so that's where you come up with your tree protection zone. And so a lot of times when you put up your fencing, you might be staying outside of multiple CRZs that you measured for multiple trees on the project. And like this line shows here, you plant your TPZ or your tree protection zone. And then you want to put exclusion fencing. So it's not good enough just to mark it on the plans and maybe stake it out. You really should put a fence, and the bigger, the meaner the fence you put up, the better. If the harder it is to take down, the better it is. I can't tell you how many projects I've been where there was a fence and then somebody took it down because it was inconvenient and in the way. And now some subcontractor who didn't know what this fence was for is trenched through there to put the hot water line or something. And you all of a sudden end up with root damage. And I've seen this happen. I was helping a friend of mine, and they didn't put up fencing, but everything was going fine until the subcontractor who was putting in the water for the hot tub didn't know. And he took the closest point from A to B, which is across the root zones of 4 trees. And all of the work that had been done with that was basically thrown out the window. So you got to put fences up, and you probably should put signage, especially if you're not going to be out there a lot. I know that on some of these big commercial projects, they'll put signage with fines in place. But depending on how big the project is, it's not necessarily always needed. Now, you're going to run into situations where maybe you're doing a grade change, whether you're dropping down outside of that critical root zone or outside of that TPZ, that tree protection zone. And you're going to want to root prune. And the cleaner the cut you can provide to that root system, the better it'll be. Ideally, the way to do it, which ideally usually means the most expensive, is to use a tool called an air spade. An air spade, and this is how this trench was dug, it shoots supersonic air into the ground, and it can basically, you can excavate with air a trench, expose those roots, and get in there with a sharp handsaw and cut away those roots. What you don't want to do is allow the guy with the backhoe to dig your trench, because what'll happen is when you sever the root that way and he pulls it out, you not only cut it here, but a lot of times you rip it on up closer to the tree, and quite often inside your critical root zone. I've seen other people use something like there's some tools used to cut concrete, some of these big blades, and if they can just put those in the ground and run it along, and you're just trying to provide the cleanest cut so that when you go through and you excavate away from that tree, you're not pulling up any of those roots. Now, you're gonna find yourself in situations where you have to cross a root zone. So you might have this huge CRZ for a tree. Maybe it's at the front of your property, the house you're building is at the back, and you're scratching your head going, you know, if I just allowed everybody to drive across this root system, they're gonna compact that soil. And so there are some techniques that are out there to try to reduce the compaction. And a colleague and I did some research at Auburn, oh gosh, it's been about 10 years ago, looking at various compaction preventative methods that are commonly prescribed, but we really didn't have any good data for them. And based on that study, we kind of came up with 3 options that are out there, and they have kind of various functions. And so the first option is what we call for a one-time or infrequent passages. And this is using something like, these are called alterna mats, you know, it's some sort of synthetic mat. You could also use plywood. And I'll tell you that in our data, we found that this did not prevent compaction. When we did the bulk density tests, the bulk density for the control against where we rolled equipment across like this was pretty much the same. What this does is prevent rutting, is pretty much it. So it's okay if you're gonna have, you know, a bucket truck come through to like trim leaves, or you're dropping off, you know, one package, you know, put the alterna mats or plywood down to prevent rutting. But if you're gonna have more frequent use, you're gonna wanna put down mulch. And it can be just basic wood chips out of a wood chipper, you know, stop an Asplund truck and get some wood chips out of the back of it. But you're going to want to put about 8 to 12 inches down it. So if you're just going to use wood chips, this is probably fine for lightweight and infrequent traffic. So maybe maybe where you're going to be stockpiling some materials around some root systems where there's not going to be a lot of traffic. They're just going to come in, put some materials down. It's going to sit there, or where you might have some foot traffic around those trees where it's not real heavy. You can put down that, you know, 8 to 12 inches of mulch to help prevent some of that compaction from occurring. Now you have to realize when you do this, you know, mulch can sometimes wash away. So you have to make sure you maintain at least 8 inches for it to be effective. Now, if you have an area that's going to be where you're going to be driving the bug, you know, everybody's going to be coming into the property, your dump trucks are coming in to lay the foundation, they're going to be dropping off all the materials, you're going to want something a little bit, a little more robust. And so this is where we recommend, you know, at least 10 inches of mulch, and then laying something like a 3/4 inch plywood or a steel plate or something on top of that mulch. And we also recommend, in many cases, underlaying under your mulch using some type of a geotextile. And that'll help the mulch from getting ground into the soil. And it also makes it actually a lot easier that when you go to remove that mulch, because at the end of the project, you don't want to leave 10 inches of mulch on there, because that can potentially limit some of the oxygen movement into the soil over time. And so what happens by having that geotextile underneath, you can just tie it to the back of a skid steer, back up the skid steer, and just pull that mulch right off at the end of the project. And I think I got some pictures here. Let's see here. Yeah, so here's a project where they're going to be, you know, bringing some heavy equipment around these root systems. They're laying, you know, the geotextile down, and then they're coming in and spreading the mulch on top of it. And then, like I said, adding that plywood on top. And our study found that while it didn't prevent compaction, you still are going to get some side. It reduced it significantly. You know, the only way to prevent it is to completely stay away from it. Then we move into the construction phase. And so this is the 4th stage. And so this is where we're looking at site monitoring. At this point, you know, you're going to be policing your tree protection zone, making sure that nobody's crossing it. You're going to stay in contact with your construction team. You're going to monitor your tree health. You know, you're going to make sure your mulch stays at the right thickness. You know, if the plywood on top is getting cracked or broken, replacing that, just making sure that all of those measures you put in place stay in place. And then you also want to be careful with this to also evaluate and monitor your landscape installation, especially if you're doing something like an irrigation system, because they're going to trench that in and making sure that they don't trench roots. And there are ways to install an irrigation system where you will have less damage on tree roots. And then we move into the post-construction phase. And so don't walk away. You're not quite done. At this point, if you've laid some of that heavy mulch because you had to get equipment across a root system, you want to remove that. And then you want to really come back and baby those trees. You have to remember, if they've lost a lot of root systems, in some ways, they're almost like a newly planted tree. And so you want to maybe come in, put 2 to 3 inches of mulch around that critical root zone. You want to monitor the trees for pests, for stress, look for any incidences of borers or anything that's happening like that. And you might even consider irrigation, especially if you've really pushed the boundaries of that tree preservation. You might consider irrigation, especially if you move into the summer months and have some type of a prolonged drought. So that brings us to the end of the presentation. And so, I like to point out that an ounce of prevention is worth a pound of cure, because I can tell you that tree preservation is not very complicated. It's really all about preserving that soil around that tree undisturbed. However, if you have compacted the soils, I can tell you that when you hire somebody to come in and decompact soils, it is very expensive. And the research behind the success of it is mixed. And so you're not sure if you're going to get your money's worth out of it. And so with that, I will take any questions. I'm not sure where I am with time. Oh my gosh, I went long. Sorry about that. So it's after 8 o'clock.
It's okay. Do people have questions for Beau? We have time.
I have a question.
Sure.
Beau, is there such a thing as a shallow-rooted species, given that soil is the same?
I think the soil influences rooting depth more than species do. But I think there is a little variability in some species to others. I think there's going to be some variability with some being a little bit better rooted than others. But I think more often than not, soil is going to play the bigger part of which trees are shallow rooted and which ones are deep rooted. Because I hear people say all the time, well, this is a shallow rooted system, and you look at their soil and it's compacted. And so, but I won't discount that some trees might be a little more shallow rooted than others.
And a follow-up, do you have a feel for what the impact is long-term on removal of organic matter from urban soils, say with backpack leaf blowers constantly removing the organic matter? What effect does that have long-term on our urban soils?
I'm not a soil scientist, but, I think you do have some major issues there. And you look at some of these trees in the urban environment and you have this really slow decline in a lot of trees. And I think it's that idea that we all want our grass under our trees, and we have all that concrete, and we have so much competition with those trees that as you're continually removing that organic material and you're not having that composting, I think you are going to see this very slow decline in a lot of our trees. And I've also wondered that, some of the products we put to control weeds in our grasses, a lot of times in our landscapes, while they're labeled for use under trees, I wonder, and this is me wondering because I don't have any data to support this, and I've spoken to some weed scientists and some herbicide specialists. If we're seeing kind of a very slow, gradual issues with some of those trees because of, it's not an acute, misapplication of herbicide, but just a very kind of long-term process. And I think it's the same with the lack of organic material in our soils. It's just, those trees are going to mine what's there, and if we don't replace it, it's gone. And that's why, everybody wants to fertilize their trees, go out there and put, throw some triple 13 down. And I can tell you, mulch is a much better long-term process. When we have to realize there's complex balances between the crowns of trees and the root systems of trees and how they move nutrients back and forth. And when we throw down a bunch of nitrogen, you can get all those trees spinning in some funky directions and get push growth where you don't need it, and end up with all these issues. And so using just a good composted mulch, while it won't give you dramatic immediate effects, the long-term effects will far outweigh those short-term ones. That was a long-winded answer to you.
Thank you.
That was a good answer.
Question?
Other questions?
Can I ask one?
Okay.
Yes, Jim, please go ahead.
Beau, I'm Jim Brown. Friends of Shades Creek kind of takes care of a 8/10 of a mile hiking trail next to Homewood High School. It's run by the
Okay.
Freshwater Land Trust. And it was started in 1960, so it's had 60 some years of compaction. A lot of trees have died along the trail, and we're trying to kind of rehab the trail. We take a wheelbarrow full of black muck from the bottom of the hill and put it over the trail, and then put some gravelly stuff on top of that. But we haven't done anything to the compacted soil when we've done that. Any advice on trail repair?
So you got a compacted trail and you're trying
Right.
to alleviate the compaction, or you're just trying to raise it up, or what?
Well, it's exposed some roots on each side, especially where it's washed.
Mhm.
And we're trying to put fill dirt back in, loam from the bottom of the hill, trying to put fill dirt in, and then a layer of gravel on top of that, kind of creek gravel to walk on.
Yeah.
But we didn't do anything.
And I'm not a trail maintenance expert, so you probably have more experience than I do with how that works. But I can tell you from a tree health, a little bit of soil fill or a little bit, it's not going to affect for that, whatever that width of that trail is, it's not going to be a big issue. But, I would guess, putting on my old forestry days, a lot of times the wash we get on our trails has to do with washing. And so any type of water bars you can do to divert that water off that trail. And, in forestry, a lot of times we would use geotextiles up underneath sometimes some of that gravel to keep it from pushing, and it kind of blending into the soil might work. Of course, all of those things get a lot more expensive, don't they? And so,
Thank you.
but like I said, I'm not an expert on trail building. Sorry. Any other questions?
We have some other questions. So Beau, with Jim Brown's question about the exposed roots, do you see that really being a huge problem in forests with trails? When you see, a trail that's washing a lot and the roots are being exposed, is that something really needs some maintenance?
I guess it depends on, the severity of it. If you have a lot of roots exposed, absolutely, it's going to dry out those roots, and, over time it'll show up on the tree. But if it's just, where you have this narrow area and a few of your big structural roots are exposed, I think your bigger issue is if they're being damaged, if there's mountain bikes or something like that that's damaging those roots, then I think it is a good idea to kind of fill it back up. But I don't know if there's any way to keep it permanent. I think it's going to constantly be an issue. But anything you could do to kind of protect those roots will help. But if it's just light foot traffic through there and it's just a small trail, you're probably okay. But if it's enough of that root system's impacted, it could cause an issue over time. And so it just depends. It's one of those things. It's hard for me without seeing what y'all are talking about. You could text me some pictures though.
Okay.
And that could work. And then maybe that would give me a sense of what y'all are talking about.
Yeah, we can do that.
And Amy's got my phone number, so.
Okay, good. We have some other questions out there. James, did you have a question you wanted to ask?
Yeah, it's not a question, it's just a sort of a point. A development that I have lifted up through the years as a example in the local area where it can be done correctly and right and leave the trees was a River Chase development now south of the Galleria on 31. And what I understand, it may just be urban legend, what I understand was when the person who developed that area years ago, he said to basically anybody who wanted to come in and build a house there, he said, sure, fine, cut all the trees you want on your lot. But in addition to the cost of cutting the tree, you had to give me $500 for every tree. Well, people didn't cut the trees. They built the houses in amongst the trees and left the trees. And now you drive through there and it's like driving through an old growth forest with houses plopped in amongst the trees. And so, you know, it's just an example locally that a developer does not have to come in and clear cut everything because somebody did it the other way and, you know, caused a penalty. And that made people stop and think about, do I really want to cut this tree or not?
Absolutely. Having those rules and ordinances in place that it's very, very helpful. And, you know, I would say that, you know, I'm seeing builders and developers realizing that, you know, trees increase property values. You know, having those large trees make those homes more desirable. But what I'm also seeing is that they're keeping the trees, but they're not using any of these preservation strategies I'm talking about. They're just willy-nilly around the root systems, cutting roots, compacting soils. And then what we're seeing is, you know, 3 to 5 years later, homeowners being very, very disappointed because they bought a lot and they love the tree. And I come out and I look at the tree, or another arborist comes out and looks at the tree and says, you know, this damage was done 3-4 years ago. And then they ask, well, what can I do? And I can tell you that there's a very short list of things you can do once that damage has been done. And they're all of them are expensive. And the results are very mixed. You know, we can try and decompact soils with using air spades, and an arborist is going to charge you like $400 an hour to run one. You know, you can try some fertilization, but, you know, the research on fertilization is it's very mixed. You know, a lot of times you're going to have to prune out a lot of the dead material out of these trees because they die from the outside back towards the center. And so that they end up with spending a lot of money. And I've had dozens of people where this has happened to. And so the message is, you know, we can preserve trees and it can be done, but you have to follow some of these basic rules. They're not complicated. It's just basically keep equipment and people off the root systems. It's very simple, and just measuring how much root systems to keep people off of, and then you'll be successful. And so it's simple, but trying to get and I got, you know, like I said, my wife's an architect, and you know, people just, you know, it's time is money and don't slow down. Just keep plugging. When the client finds it's important, then it usually works.
Mm-hmm. Okay, we have a question here on our chat line. It says, are the burrows for species such as the gopher tortoise healthy or harming to the trees?
Oh, you know, they'll be fine. You know, a gopher tortoise is not going to damage a root system. They're going to go around those root systems. And you know, gopher tortoises are kind of down here on the Gulf Coast, right? So they're going to be dealing with sandy soils, usually in a pine ecosystem. And so, burrows are not an issue at all. Yeah, you know, they're not going to try to dig through a 3-inch root.
So if you have a large mature tree that has some tip dieback, like you were talking about, because of maybe partial, you know, maybe the lot next door had some compaction, is it to the tree's advantage to cut those off, to cut off the tips?
Not necessarily. What it usually is to the advantage is it's to the homeowner's advantage if those branches are going to fall on you or your home.
Okay.
So the tree is going to wall off that decay. And so a lot of times it's either a safety issue or it's just unsightly. And so that's usually what it comes down to. It's kind of like trees shedding interior limbs because they've shaded them out. You know, you don't have to get in there and prune all those out, but when they get big enough and fall on, I got massive live oaks. You know, this picture here is my house, not my house, but my property. And these live oaks drop big limbs and they can be a problem. So.
Well, do you have any sense of the importance of provenance in urban trees, like particularly north-south gradient? What should our seed sources be, and is anybody paying any attention to that?
It is important. I think, you know, because, you know, we end up with challenges because a lot of especially a lot of the nursery stuff we get, you know, the seed sources for some of that stuff is who knows where it's coming from. And I think the more locally sourced we can get our plant material, the better it's going to do. And so, you know, I think, you know, for down here on the coast, you know, I encourage people to get stuff out of nurseries, you know, probably from the coastal plain between, you know, Louisiana and the Florida Panhandle, and, you know, try not to get things from the Birmingham area, you know, because, you know, the soils are different, you know, the seed sources are different. But the problem is with the nursery trade is, you know, sometimes those liners came out of the Pacific Northwest, or they came out of the Ohio Valley. And so that's pretty tough. But is anybody doing anything? I don't know. I don't know. I know it's paid attention to, and I know that some people are looking into it, but I don't know who specifically. But, you know, can we buy anything? I don't think so. But I think it is important. I mean, if you can, the more locally sourced you can buy, you know, down here, and we're missing out on so many great species that the nursery trade doesn't have. You know, down here, the only maple I recommend anybody plant certainly south of Montgomery, and really even south of, is, you know, something like a Florida sugar maple, Acer barbatum. You know, but a lot of the reds and stuff, they can't handle our coastal plain, the heat. We end up with so many issues. And, you know, we get a lot of transplants down here and people moving in from, you know, the Midwest and trying to plant, you know, silver maples and red maples, and, you know, the seed sources for those are coming out of the Ohio Valley or Tennessee, and they don't make it.
Thank you.
Yeah, thanks. This is a great program. A lot to think about, and especially if you're thinking about building or watching somebody else build. It's some great pointers. Do we have any other questions for Beau while he's here with us?
Michelle, I'd just like to say that I think this topic is extremely important for watershed quality. We talked about riparian trees. They're not just the ones immediately adjacent to the creek that matter. It's the entire watershed. I think the more we can protect our urban forest from throughout the watershed, that's going to help stream quality and water quantity as well. So I urge everybody to think in terms of stream protection. Thinking of the green infrastructure throughout the city is, you know, really contributes a lot to stormwater and water quality and quantity.
Totally agree. I wish we could have all the developers in the area listening to this program. I think it would benefit homeowners and especially trees. But I will say that we are recording this tonight, and so we'll have this out on our website. So if you know of a builder, or if you know of somebody who wants to get this information to their builder, we will have this available. So, and I hope you don't mind us doing that, Beau.
No, that's fine. That's fine.
Something sort of little bit peripheral, but I wanted to get your take on it. There's a huge amount of directional boring going on in the Birmingham area because they're putting in high-speed internet type cable underground all over the Birmingham, Jefferson County area. So they've got spots, they'll use a machine, they'll go underground, they'll bore so they don't have to disturb people's driveways, et cetera, et cetera. Do you have any take on how much that is harming trees or whether they're often enough underneath the root system that they're not harming them, or do you have any feel for that?
A little bit. I actually had to look into this. Gosh, it was about this time last year. Actually, the community in this background of my image, this is Magnolia Springs, Alabama, and they got tired of the utility company having to trim one side of the trees on this, and so they were looking at boring under all of those beautiful live oaks planted in about the 1930s. And so I did a little bit of looking, and I will tell you, there's not a lot of research out there on it. And so what I basically found is the recommendation is if you can ensure that with the boring, you're staying at least 2 feet down, preferably more, but if you're at least 2 feet down and you're going to be under the vast majority of the root system of the trees. You might hit a few sinker roots. And so if you can stay away from being directly under the tree, that would be better. If you can be offset a little bit, that'll help. But the issue I see and the issue I saw with this project is and this was for power, but when they have to come back up, and when they come up, they normally have to dig these pits down, and if those pits are too close to trees, that's where you end up. So you end up with this directional boring that saves one thing. So you just got to make sure when they come up, that where they have to put those pits in, where those pipes come up, that they're not disturbing the roots at that point. And that's what killed it for this project, because these live oaks were planted very close together, in many cases probably too close together. And the pits would have to come up right between these trees, would have been within the structural root plate of both trees. And I couldn't guarantee to anybody in the community that it wouldn't cause detrimental damage to those trees. And
Yeah,
so,
all over here, they're putting like 3 feet by 4 feet in bigger boxes where
Yep.
they're connecting, where they come up and
Yep.
sinking those boxes. And the most disturbance I've seen is around those and installing those boxes.
and that's where I was concerned. I figured with once the bore's underground, I think it's very minimal. It's where those boxes come up. That's where, they're coming up on one near your house. That's where I'd want to be negotiating with whoever's doing it, depending on how close they're coming to one of my trees.
And there are hundreds, maybe thousands of those going in all over Jefferson County.
Wow. I guess was that, let's see, the city forester in Birmingham's Randall, right? Randall. So I think that's education for those clients, if they, where they come up and how much damage they're going to do those roots. So.
All right. So do we have any other questions before we let Beau go tonight? We really appreciate all your time.
Absolutely. This was great. And if I can ever be of service, let me know, and I will, if y'all ever need any other presentations, I'm willing to come back, and I got some other folks I could point you towards who might give you some good presentations too. So
Oh, that's great. Yeah. We will look at your other presentations and see what else you have available. That's a great idea.
I heard you guys talk about riparian zones and if you haven't had Eve Brantley on, she's fantastic. One of our colleagues that works with water resources at Auburn Extension too. So
that's a good suggestion. And so I just have one last comment from somebody. This is from Betsy Dobbins, Dr. Dobbins at Sanford. Thank you for the important program. And if there's no other questions, I just want to thank you for being here. I've learned a lot, and it's a lot to think about. And definitely, if anyone's building, to plan ahead, not just with your building plans, but with your tree plans.
absolutely. Well, thank y'all and have a good Thursday evening. And hope to see you all around sometime.
Thank
Right.
you, Beau.
Thank you,
You have
Beau.
a good Friday.